everyone, my name is Abhidhnya Patil. Today I am going to present optimization of loss function and best fit line using gradient descent under the subject exploratory data analytics. To understand gradient descent, first we need to understand regression. Regression is supervised learning technique used to predict continuous values. For example, predicting house prices based on a area. The aim is to find a relationship between input x and output y and represent it through a line. The equation of this line is y equals to mx plus c, where m is slope and c is the intercept. Our main goal is to find the best values of m and c so that the predicted values are so close as possible to actual values. Now, what is the best fit line? The best fit line is the straight line that shows the most accurate relationship between the independent variable x and the dependent variable y. It is the line that minimizes the overall difference between the predicted values y cap given by the model and the actual values y from the dataset. This difference is known as the error or residual, calculated for each data point as error equals to ym minus y cap n. A good model means these errors are small. So the best fit line is the one that minimizes the total error across all data points. Therefore, the best fit line is the one that passes as close as possible to all data points, ensuring the minimum overall error and maximum prediction accuracy. To measure how good our line is, we uses a loss function or a cost function. The loss function is also known as the cost function, is a mathematical measure that tells us how well or poorly our regression line fits the given data points. It calculates the difference between the actual output y and the predicted output y cap for all data points. The most commonly used loss function in linear regression is the mean squared error, that is MSC. The squared term ensures all errors are positive and large errors are uh, penalized more. Our aim is simple. Minimize the loss. A smaller loss means our model fits better. This is the formula of MSE. Here, n is number of data points, y is actual value, and y cap is a predicted value. Once we know our loss, we need a method to reduce it. There is where gradient descent comes in. Gradient descent is an optimization algorithm used to minimize the loss function in machine learning models like linear regression. It helps the model finds the best value of slope m and intercept c that gives the lowest possible loss. The idea is simple. Start with the random values of m and c. Compute the loss using the loss function. Then move step by step in the direction of the steepest decrease in loss. These small steps continue until the loss value cannot be reduced any further. At that point, we have reached the minimum loss and obtained the best fit line. It's called gradient because it uses a slope derivative of the loss function, and descent because we are moving downhill towards the main point. This continues until we reaches the lowest point, that is the minimum loss. The algorithm updates m and c in small steps. Each step is guided by the gradient, which means the slope of or a derivative of loss function. The updates are based on the derivative gradients of the loss function with respect to m and c. This gradient these gradients tell us the direction and rate of change of the loss function. The process continues until the loss becomes minimum, meaning that means the further updates don't make much change. The update formula includes a term called the learning rate alpha. If alpha is too small, learning becomes slow. If alpha is too large, the algorithm may overshoot the minimum and never converge. So choosing a correctly is very important. Uh, this is the general update of formulas of gradient descent, where alpha is learning rate, a small positive constant that controls how big each step is. Dou L by dou M and dou L by dou C are gradient slopes of the loss function with respect to M and C. Gradient descent works in a simple sequence. First is initialize parameters. Start with the random values of slope M and intercept C. Second, predict outputs using the equation y equals to mx plus c. Third, calculate the loss using mean squared error to check how far predictions are from actual values. Fourth, compute gradients. This tells us the direction of the snippets uh, increases with respect to M and C. Update for fifth, update parameters. Update M and C using gradient descent formulas. This is the formula. M equals to M minus alpha into dou L by dou M, where M is a slope, and C equals to C minus alpha dou L by dou M, where C is intercept. Repeat this process until the loss becomes minimum or stops changing. At this stage we find our final best fit line. The learning rate alpha decides how big a step we take in each update. A small alpha like 0.001 means the model learns slowly, takes many iterations to reach the minimum. Large alpha like 1.0 may cause the model to overshoot, causing the loss to fluctuate or even diverge. A properly chosen alpha ensures faster and stable convergence. Common practice start with small values like 0.01 or 0.001 and adjust based on the uh, performance and adjust based on how fast the loss decreases. Let's consider an example where X is studied and Y is marks obtained. Initially, a prediction may be poor, but after running gradient descents for several iterations, the algorithm gradually adjusts M and C to reduce loss. Uh, this is the example data uh, of our studies and the marks. Eventually, we may get a line like y cap equals to 10x plus 30, meaning every extra hour of study increases predicted marks by around 10. Uh, After several iterations, the line starts fitting the data much better. For instance, predicted around 42 marks for 1 hour, 75 marks for 4 hours, etc. We, uh, this shows how gradient descent improves model accuracy step by step. As the algorithm continues updating M and C, the loss keep in, decreasing. With every update, the loss error gradually decreases, meaning the line is getting closer to the best fit. This process continues until the loss becomes very small or almost constant. This point is called convergence. At convergence, the algorithm has found the optimal values of M and C, which define the best fit line. Thus, the model now makes the most accurate prediction possible for the given data. To conclude, regression helps predict continuous values. The loss function tells us how far our predictions are from the real values. Gradient descent helps us minimize the loss by adjusting parameters step by step. Finally, we obtain the best fit line which represents the data most accurately. In simple words, optimization means reducing loss to get the best possible prediction model. Thank you.